5.1 and 5.2 is 5.1, we won't know what we're trying to break it down to. 5.2, where it says verifying, it'll tell you what it's supposed to kind of be broken down to in the end. Essentially, they're the same thing, except we don't know what we're trying to find. You just have to feel good about, yeah, I got the answer. Whereas in 5.2, they will tell you what the answer is supposed to be. So like you already know the answer, you just got to get there. And that's what makes it kind of hard. Because like when you know the answer and you can't figure out how to get there, that's frustrating. Because they really give you the answer. So that would be the difference between those two. 5.3 is solving the equation. So we'll use the identities to help us solve for x. And then 5.4 and 5.5 are more equations and more identities and formulas. By the end, we'll have in between like 40 and 50 that need to be memorized. And that will like 5.4 and 5.5 have it like another group beyond what's on your sheet. So looking underneath, you know, it sounds like fun, right? I'm selling it. It's lots of fun. I did really like it. I love it. It's great. Not hard, just fun, challenging. Like, just. All right, so expression is a combination of trig functions. So we talked about combining functions in chapter 1, algebraic functions. And that was taking like f of x times g of x, f of x times, or plus g of x, f of x divided by g of x, f of x minus g of x. That's all the combinations. So how can you take two functions and combine them together? The goal is to simplify to one term. And if we can't get it to one term, then there better not be anything else we can do with those terms. So maybe it might say sine x plus cosine x, and there's nothing else we can do with it. But our goal really is to get it to one term. So an example might say sine x times maybe cotangent x. So that might be what a problem looks like, and the directions will say to simplify. So we'll be trying to use a trig identity to break this problem down so that in the end, instead of having two functions, we end up having one. So that would be the goal, to break it down using a trig identity that's simplifying. So an equation has what in it? What's an equation have, Chelsea? An equal sign. Yeah, so this is still talking about trig, but it has an equal sign. Oh, that's supposed to be equal sign. The goal of an equation, Chelsea, is usually to find x. Yeah, so we're going to be finding x except in trig, when we solve an equation, and here's my example, sine x plus 1 equals 0. What does that x represent in trig? Not just x. The angle. Yeah, so when we find x in trig, we're finding the angle, which we've already done, because every time we use that unit circle, we know that the inverse functions, if the sine is equal to the square root of 3 over 2, we're solving for the angle, so now our equations are going to be a little more involved. So we'll still be using that thought process of finding the angle in the unit circle, but we'll be trying to work on trig equations that have multiple functions. I heard Mr. King calling you yesterday. You had your hand raised.
I had my hand raised for 10 minutes.
Yeah, he kind of felt bad. Usually he doesn't feel bad, but he actually did. He must like you, Kate. And then the last thing is an identity, and that's just a trig fact. A fact is something that holds true for all values in the domain. So on that identity study sheet, those are all trig facts. So sine squared plus cosine squared equals 1 is a fact that holds true for any value of x, because the domain for sine and cosine is negative infinity to positive infinity. So as long as I use the same x value, pi over 3, when I take the sine value of pi over 3 and square it, in addition with the cosine value of pi over 3 and square it, no matter what, it's going to equal 1. So that's just a fact. Same thing with the rectangle has four sides, 4 right angles, 2 pairs of parallel sides. Those are facts about triangles. Facts about trig or identities. So if you flip the page, the first type of problem that we're going to solve dealing with identities is more thinking about it numerically, just to get you kind of used to trying to look at an identity and use it with a numerical value. And then the other examples we will look at are going to be the simplifying examples. We're going to start off with numbers first. I'd say very rarely will we use a calculator unless it's a word problem, which we're not going to do word problems until we get through a little bit of 5-3. So there's really no calculator necessary. I think like in the book it might say like you can graph it in the calculator to verify your response. Don't worry about doing that. So no calculator necessary for a while. So Nina broke her calculator. I don't think she has a new one yet. She's good to go for a while.
Probably not. Do it for a while.
For a while. So example 1 is very similar to something we did in chapter 4. Use the fundamental trig identities to find sine and tangent, which in chapter 4, if we did this problem, it would just say find sine and tangent given that, and whatever the information is they give us. It wouldn't say use the fundamental trig identities because we draw the triangle. And we'd make sure that triangle was in the correct quadrant. We label the sides of the triangle based off of the secant is the hypotenuse over the adjacent side. We find the other side. So instead of doing the triangle stuff, because we're kind of done with triangles for right now, yay, maybe, we're going to try and use these trig identities, but I still need you to think about the unit circle and where the angle would be located. So if you look at the information they give us, it says the secant is negative 3 over 2, and the tangent is greater than 0. So if it were an angle in one of the 4 quadrants, where would it be located if we have the secant being negative 3 over 2 and the tangent is greater than 0? It would be in the 3rd quadrant. So in the 3rd quadrant, tangent is positive. Tangent's also positive up here in the 1st quadrant. But the secant and the cosine are negative. Also in the 2nd quadrant. So because both of those pieces hold true for the 3rd quadrant, our angle would be a quadrant 3 angle. Now that part is important because when we go to get answers, we need to make sure our answer is positive or negative based off of the fact that we're finding the sine and the tangent. And sine should be negative in the 3rd quadrant, tangent should be positive. So that's why we have to kind of think about that. All right, so how do you work through this problem? We're finding sine and tangent. What could we find first if we know the secant is negative 3 over 2? What's easier to think about? Virginia? Okay, so it is hypotenuse over adjacent, but if I don't want you to think about a triangle, what else could you use to think about secant? 1 over x, or 1 over, what is x? What function represents x? Asia? 1 over cosine. So Asia, if the secant is negative 3 over 2, the cosine would be negative 2 over 3. So sometimes instead of thinking of it in terms of secant, sine and cosine are easier to go back to. And we'll use sine and cosine a lot because they're the 2 functions that we started with. All right, so if you know now that cosine is negative 2 over 3, and we want to find sine and tangent. Make sure you grab a packet, friend. Sure. I was leaving it open just for you. Sure. You had an early dismissal and you came back?
I got my braces taken off and I had to come back to work on the Shakespeare monologue,
Oh,
and
okay.
I came back early.
So you were supposed to say yes. Of course I'd come back to math class.
I could have gone up to Miss Morby's and no one would have ever known.
True. I would have looked. All right, so how do we use cosine to help us find sine or tangent? Look at your trig identity sheet. Is there anything on there, that identity sheet, that helps us relate cosine with sine or tangent so that we can find one of those two. Sabrina, what do you think? Is there something on there that relates cosine with sine or tangent? Okay, so she said the tangent is equal to sine over cosine. So we know cosine, but unfortunately we don't know sine or tangent. And in an equation, you have to know two of them to find the third. So we can't use this yet. Can't use that identity yet because we don't know enough pieces. But is there something else on that sheet that we could use? Virginia. So she said we could use 1 plus tangent squared x equals secant squared x. So that's one option. Is there another option that we could use? So there's a lot of options. How can we find sine? Michael?
You do the cosine of pi over 2 minus x is equal to the sine?
If I had information about the cofunction angle. So unfortunately, no. Gray thought of that this morning too. Because it just gives us like the angle, it would have to also give us something with that x minus pi over 2 with the angle. Sabrina?
Could you use sine x squared plus cosine x squared?
Yeah, that would be another option that we could use. Brandon, were you going to say that as well?
Do we have to use identities or? can we
Yes.
So we can't just
No.
draw
We're done with triangles. Taking a break from triangles for a little while. Okay, so Virginia said 1 plus, you said 1 plus tangent squared x equals secant squared, right? So you could use that, or you could use sine squared plus cosine squared equals what? Either way, you're either going to find the tangent or you're going to find the sine. So why don't we start by finding sine since we have cosine. So when you're using an identity and you're plugging in a number, literally you have the cosine. So we're taking cosine out, we're replacing it with the number that represents cosine. So there shouldn't be an x because all of this is replacing it. So we have negative 2 over 3. That number is squared because cosine was squared, and that's equal to 1. So there's no x remaining because the cosine x, I guess that should have been an x, not a theta, is equal to negative 2 over 3. So now you plug it in. You got to do a little bit of solving. So here comes the algebra, pulling algebra back into Trig. Brandon, what is negative 2 over 3 squared?
Hold on, I'm still writing notes.
Oh, I'm sorry. I can ask somebody else. Libby, what's negative 2 over 3 squared?
4 over 9.
4 over 9. All right, and then taking the 4 over 9 to the other side, Libby, 1 minus 4 over 9 is?
5 over 9.
Nice job, 5 over 9. Okay, so you plug a number in, you square it, you take it to the other side because our goal is to solve for the sine. We want to know what sine is. So if you have sine squared, what would you do to just get sine? Chelsea?
You take the square root.
Yeah, take the square root. Just like if it was x squared, you take the square root. So sine squared is the same thing. It's a function. X is a function. Sine is a function. So now we just have sine. When you take the square root of 5/9, you can't take the square root of 5, but we can take the square root of 9. Oh, I didn't take the square root of 9 there. There we go. And Chelsea, every time you take the square root, what goes in front of it? A plus or minus. That plus or minus is actually important because our angle is located in the third quadrant. And you have to choose between the plus or the minus, and it's a minus because sine is negative in the third quadrant, as well as cosine being negative in the third quadrant. So between the plus or the minus, we actually need the minus part because it's a quadrant 3 angle. So using the identity, that was the Pythagorean identity, sine squared plus cosine squared equals 1, we could find the sine by plugging in the cosine value and then working through it algebraically, trying to get sine by itself. Questions? All right, then the second part, you can find two ways. So Sabrina said at the beginning, tangent is equal to sine over cosine. Virginia said you could also use 1 plus the secant squared equals the tangent squared, so you could use either one of them. It's up to you, whichever you find easier to use. So if you want to solve for the tangent using the fraction, we just found sine to be negative square root of 5 over 3. We knew cosine was negative 2 over 3. So you could just plug it right into the fraction, or Virginia, you can use the Pythagorean identity as well. You're going to get the same exact answer. So when you're dividing by a fraction, you really multiply by the reciprocal, so flip this guy around. That would be negative 3 over 2. So therefore, the tangent of x, our 3's cancel. We have a negative and a negative, making it a positive, square root of 5 over 2.
Why would you put in the sign as negative? Oh wait, never mind.
Okay,
Yeah, sorry.
no, you're good. Any other questions? So 11, 15, and 17 are 3 problems where you're just kind of evaluating for trig functions, not using a triangle, but instead trying to just use the identities. Questions? So the other 3 problems on this page are the actual simplifying identities problems, where now instead of having any numerical values, we have a combination of trig functions. So if you look at example 2, it says transform the expression, this is an expression, you have 3 things that are being multiplied together, into the value of 1. So here you know what it's supposed to be. In most cases, you're not going to know what it's supposed to be. So this one tells you whatever we have here is supposed to go down to the value of 1. So if you look at your identity sheet, we're going to use some substitution in algebra to help us transform this to become the number 1. So what kind of identity can we use? Just kind of look, see what do you have in the problem. How does an identity fit with one of those pieces of the problem that you have? So we've got sine, secant, and cotangent. Liddy.
Oh, I don't know if this is what you want, but cotangent can equal cosine over sine.
Perfect. That
And
works.
Yeah.
Okay, so let's start there. We'll do one thing at a time. So she said cotangent, and that's the quotient identity that she gave me, is equal to cosine over sine. So that's using substitution. You're taking out cotangent, you're replacing it with whatever it's equal to. So we use the identity to take one part of it out and replace it with something else. All right, so let's continue trying to use an identity. What other identity can we use? Okay. The secant can be changed to 1 over the cosine. And all these are still being multiplied, so if it makes you feel better to put a multiplication symbol in there, you can. It's still multiplication just because we're changing the identity, or replacing the identity. And if you like seeing the sign as a fraction, feel free to make that as a fraction as well. And then Kate, what happens with all this stuff?
The cosines cancel and the sines cancel.
Yeah. So the cosines cancel. The sines cancel, even though they're not next to each other, everything's still being multiplied. And as long as one term is on the top, identical to a term on the bottom, somewhere on the bottom, they all cancel. And now we have the number 1. So when you get down to a single number, or if we got down to a single trig function, then we would know that we've completed the problem, we've simplified it. This would told us it was supposed to be equal to 1. But if it did tell us that, and we still broke it down and got down to a single value, then we would know it's simplified. Questions? So we used 2 trig functions, substituted whatever they were equal to into the problem. So you took out a function, you replaced it with what it's equal to. Good. So if you look at the next group of problems, again, the directions say to simplify, which is I think what the directions say for your homework. And otherwise it doesn't give you any other information, just to simplify. So this is where it becomes more of a puzzle. So you kind of have to decide what can you take out of the problem and replace it with. So what part can you take out, replace it with a trig identity? Or is there an algebraic step that you can do to try and help solve the problem? Because sometimes there's algebra involved that you might have to use along with identities. So again, like right now, like this is only the second problem we've done, but it really is, you have to be willing to try something. And if it doesn't work, you scratch it and you start over. But just looking at your identities and the problem, like is there something we can use to switch something out? Or maybe there's like a math thing that you can do. Maybe there's some kind of algebra that you can do. Brandon, what do you think?
Can we use the negative angle identities to change that to sine negative x, or would that just not help us at all?
So you would change like the negative sine x to be
Like sine negative x?
so the x in a parentheses would then become negative.
Yeah, I don't.
So yeah, that probably wouldn't help us. Yeah, by making an x negative. Chelsea, what do you think?
You can cancel out the signs.
Why can you cancel out the signs?
One's positive, one's negative.
Okay, so she said you could try and cancel out the signs because one is positive, one is negative. And that would work if those two were separated. So if this said sine separate from cosine, then we could cancel them out. But because these are being multiplied together, this is like having xy squared minus x, and these aren't like terms. So if they're not like terms, we can't really combine them together. But like you're thinking, so that's good. Like thoughts are good. Libby, what do you think?
Do you make the cosine squared 1 minus sine squared?
Okay, can you tell me that identity that you're using?
It is Pythagorean identities, and it's the sine squared plus cosine squared equals 1. But it also could, like if you subtracted the sine squared to the other side, it could be cosine squared 1 minus sine squared.
Okay, so just to kind of get you to see what she is looking at, there is a cosine squared in this problem. An identity, the three Pythagorean identities, can be rearranged. So just because this says sine squared plus cosine squared equals 1, it doesn't have to stay like that. So if there's a cosine in the problem and it's cosine squared, we can take the sine to the other side by subtracting it and have this same identity but kind of like flip-flopped, say cosine squared is equal to 1 minus sine squared. So here's your sine squared plus cosine squared equals 1. If we want to just solve for cosine squared, you can rearrange the identity. That's what you're allowed to do. So if you rearrange it, here's the part that we're going to be substituting. So we're going to take out cosine squared because cosine squared is equal to 1 minus sine squared. So we're still using the identity, but we just kind of switched the identity a little bit. So there's a sine here. That's still part of the problem. We're taking out cosine squared and replacing it, because it's a quantity, I'm going to put it in parentheses, with 1 minus sine squared. That's substitution. So you're still using Pythagorean identity, we just rearranged that identity a little bit. And it says minus sine x. So this is the piece that we changed because there was a cosine squared. So we replaced cosine squared with 1 minus sine squared. So Libby, why did that help?
Because then you can distribute the sine to that, because it's
Yeah, so now it separates those pieces and we can distribute the sine through. Libby, what do you think sine times negative sine squared is?
would it be sine cubed?
It would be sine cubed. Just like x times x squared is x cubed, sine times sine squared is sine cubed. So Chelsea, now
You can cancel out the sine.
you can cancel out those signs. Because now they're separate. Because you now have 3 separate pieces. And a positive sign minus a sign cancels, and you're left with negative sine cubed of x. So yes, it's cubed, but we're down to 1 function. That was a little tricky. Kate, I know you had your hand. Did you do the same thing?
I added sine next to the other side.
Okay, so is there an equal sign? No. So we can't place an equal sign in there, unfortunately. if there's not an equal sign, we can't add an equal sign into the problem. We kind of just have to keep it as it is. The only thing we can do is rearrange an identity because that has an equal sign. Questions? All right, so let's see if we can kind of look at this last problem. So sine plus cotangent times cosine. These are being multiplied together. There's an addition sign, and then the sign is separate from it, but cotangent and cosine are being multiplied together. Virginia, what do you see?
Well, I was just gonna change cotangent to 1 over tangent.
So she said, let's change cotangent to 1 over tangent. What else could you change it to?
And the tangent would be sine over cosine.
Or what's cotangent? We already have cotangent. What can we change that to? You're on the right track.
Oh,
Yeah, so it's fine, like you just have 2 extra steps, but if we have cotangent, cotangent is cosine over sine. Again, this is multiplication, so this is times cosine. I'm just going to place all these fractions over 1. I like seeing fractions grouped together. So these 2 pieces, if you multiply them together, there's a plus sign. Cosine times cosine is cosine squared. And then how do you add fractions together, Brandon?
You have to do it the same way, so you multiply a sine by sine to get sine squared plus a cosine squared, and then that would just equal 1.
So he said multiply the denominator on the left by sine so that the numerator becomes sine squared. There was already a cosine squared. A common denominator means they can combine in the same fraction. So getting the fraction on the left to have a sign on the bottom, you do the same thing to the top. And now this top part just becomes 1. Because sine squared plus cosine squared is equal to 1. Brandon, what is 1 over the sine equal to?
That is just equal to cosine.
When it's not in a fraction, you've got it down to 1 function, then it's been simplified. That one's, to me, kind of cool, because you kind of start with a fraction, 2 separate pieces, combine it together, and you just get down to 1. Living.
I don't think it would like solve, but like for like another problem if it did, would it work to do like the cotangent and then cotangent squared?
If it's squared, yes, like your term has to be squared in order for you to use it.
Okay. Could I make
Is anybody interested in trying 17 or 35? Libby and Brandon? Libby, which one would you like to try? And Brandon, you'll try 35? So you have to give these a chance. You can't give up on the first shot. And I tried to assign ones that were like a little more straightforward than what they will be on Monday. Have an awesome